Hello class, today we're going to be learning lesson 2-5 in our textbook, which is all about learning how to reason using properties from algebra. Okay, so we're doing a lot of logic now, remember? A lot of proving things that we already were assuming. And so today we're going to be talking about many of the properties that we've already known. So when you solve an equation, you're using properties of equality every time you try to solve. So let's list out some of these different properties. The first one is, for all of these actually, let us assume that A, B, and C are real numbers. Okay? So if A is equal to B, if that's something that we're given, then I can change it by saying A plus C is equal to B plus C. Right? If I just add the same number, C, to both sides, this is still going to be equal. And this is called the addition property. Okay. Likewise, if I start with A is equal to B, then A minus some number, it should be the same as B minus that same number C. This is the subtraction property. Moving on from that, if A is equal to B, I can multiply each number by a different number. So let's say A times C. If I multiplied the left side by C, I could do that with the right side also. Have B times C, and both sides would be equal. This would be the multiplication property of equality. You know that I can also divide both sides by the same number, and they would still be equal. So if I divided both sides by C, this is called the division property of equality. And finally, if A is equal to B, then A can be replaced by B in any equation or expression. This is known as the substitution property. Okay, so we're going to start out with these 5 properties. And what I have for you now is a typical problem that you would have seen in algebra. And we're going to solve it. Okay, so we're going to find out what x is. But every step of the way, we're going to give a reason for that step. So if I want to find out what x is, I think first what I would do is I would add 3x to both sides, because I'm going to combine the variables. All right. So if I'm adding something to both sides, I can justify this by saying I'm using the addition property of equality. Okay, and so I'm going to combine those, and I'm going to be left with 5x plus 5 is equal to 20. So then my next step is I'm going to subtract 5 on both sides. So if I'm subtracting a number on both sides, I can do that because of the subtraction property of equality. A lot of writing. Okay. So then I'm going to rewrite this, and I'm left with 5x is equal to 15. And one more step to get the x by itself is I'm going to divide both sides by 5. And I can do this because of the division property of equality. And I'm left with x is equal to 3 as my solution. So this is kind of that thought process of what we're going to be working on in this lesson, is being able to go back to those properties that we already know and be able to justify all of the steps for why it's okay to do what we're doing to solve an equation. Moving on, we're going to look at the distributive property. So this is another one that you've worked with many times before. And we know for the distributive property, if A, B, and C are all real numbers, and I have A times the quantity of B plus C, I can rewrite this by using the distributive property, which means AB plus AC is the equivalent side of this expression. Okay? So we're going to use that to help us justify solving this equation. 60 is equal to negative 3 times 8x minus 4. So at the very beginning, I'm going to kind of distribute this out. So I'm going to rewrite it. 60 is equal to negative 24x plus 12. And I'm going to justify that by the distributive property. Next, I'm going to subtract 12 on both sides so that I can get the x by itself. And I can do that because of the subtraction property of equality. So I'm going to rewrite this. I'm left with 48 is equal to negative 24x. One more step to get the x by itself. Divide both sides by negative 24. And I can justify this by the division property of equality. And then I have come up with my final answer. Negative 2 is equal to x. Or I can put the x first and say x is equal to negative 2. Okay, so this is stuff you've done all along, but now I'm just showing you the different properties that you can state to justify your reason for doing a specific step. I have many properties here. I think maybe I'm going to cover up some of these so you're not overwhelmed. The following properties are true for all real numbers, which means since a line segment length and also an angle measurement is going to give me a real number, it's going to work for all of these. So the first one is called the reflexive property of equality. So if I'm just talking about a number, I can say for any real number A is equal to A. That is what the property says. It's reflexive. Okay, it's kind of just saying 2 equals 2. If I'm talking about a segment length, then I can say for any segment AB, well then the measurement AB is equal to AB. That's kind of a given. All right. And same thing with an angle measurement. For any angle A, the measure of angle A is equal to the measure of angle A. It's kind of just stating the obvious, but this comes from a property called the reflexive property of equality. Okay, moving on to another property. This is the symmetric property of equality. So we're looking at symmetry. Okay, let's move this up so you can see it. There we go. So this one says for real numbers, for any real numbers A and B, we're going to say if A is equal to B, then I can also say that B is equal to A. I can kind of reverse the order, and this is symmetry. It's going to be the same on both sides, however I reflect it. So for segment lengths, for any line segments, AB and CD, I can say if AB, if the measurement of AB is equal to CD, then also I can write it as CD is equal to AB. And for the third one, for angle measures, for any angles A and B, if the measure of angle A is equal to the measure of angle B, I can flip that around and say, well then, the measure of angle B is also equal to the measure of angle A. Again, a lot of these just kind of seem like stuff that you already know, but now you have a property to justify why it's okay to state that claim. The last one is called the transitive property of equality. And for this one, we're going to start with the real numbers, and we're going to say for any real numbers a, b, and c, if a equals b and b equals c, then I can assume that a is also equal to c. All right, this is very similar to what we learned already this year in geometry. For segment lengths, I can say for any segments AB, CD, and EF, if AB is equal to CD, and if CD is equal to EF, then the measurement of AB must be equal to EF. And finally, for angle measurements, for any angles A, B, and C, if the measure of angle A is equal to the measure of angle B, and the measure of angle B is equal to the measure of angle C, then I can assume that the measure of angle A is equal to the measure of angle C. All right, well, let me move that so you can see that a little bit. Awesome. So we're going to do one last example. And what it says is, in this diagram, we're given that AB is equal to CD. And I want you to show and justify your steps to show that AC, so all the way from A to C, is going to be equal to the measurement of B to D. So here's how we're going to do it. We're going to start with what's given. AB is equal to CD. The step that I'm going to say is it's given. That's my reason. I can already assume that. And I'm going to look at AC, and I know that this is the sum of AB plus BC. And this was something that I learned way back in lesson 1-2. It was because of segment addition postulate. Okay. So also I could say then that BD is equal to the sum of BC plus CD. And again, this is because of segment addition postulate. So look what I have here. AB plus BC is equal to CD plus BC. This is because right here I said in this line that this is AC, and I said that this right here is BD. This is from the addition postulate of equality. And if I substitute saying that AB plus BC is equal to AC and substitute the other side, this is because of the substitution property. So in the end, I can justify and say that AC is equal to BD. And I'm done. So I know this might be a little confusing, but we're going to definitely go over it in class. So what I want you to do before you come back to class is, on your own, I want you to solve the following equation. And just like I did in the notes, give a reason for each step using any of those properties listed in this section. And I'll see you when you come back to class.